Okay, AP Calculus, AB, Unit 6, 1, last unit of the first semester. This is a warm-up, and we are going to be doing some new stuff today, but you should be able to do everything in this warm-up based off of our previous units. And this is a free response question, which I think we've been avoiding for the most part. So just some quick, just little things about free response questions before you go ahead and try it yourself. So free response questions, you can write this down also, just a little information. There are 6 on the AP Calculus test, and they equal 50% of your test score. And you also are given 50% of your test time. So 6 of them, you get hour and a half. 6 of them would equal 15 minutes each on average. Some might take you longer, some might take you less. They're equal. They add up to 9 points each on the AP Calculus exam. Other AP tests that might be worth different. And to get a 5 on the AP exam, you need about a 75% to get a 5, which is considered an A. So, you can get away with getting a C as far as what you're normally used to and getting a 5. So on this question here, this would be 9 points total. And this one was broken down into 2 points, 2 points, 3 points, and 2 points. So I'm going to tell you where to get the points. And that's going to be something that we're going to spend time on as we get close to the test, just really being aware of where the points come from. So go ahead, pause video, and try this first problem. And after you've tried it, then you can go ahead and watch the rest of the video and see how you did and make corrections and see where the points come from, not just did you get right. And it is a lot about showing the work to get the full credit. The final correct answers are usually only worth a fraction of the total points. It's the work leading up to the answers that you need to make sure you show clearly, communicate well, show critical calculus ideas, make sure things are labeled. So go ahead, pause it, and try it for yourself. And give yourself, try and finish it in 15 minutes or less. As soon as you're done, you can unpause it and grade it and fix it. Okay, assuming you tried it, says that you want to show that dy dx is equal to this. Instead of just saying find dy dx, which they totally could have done, they're saying, hey, this is the answer. Can you get this answer? So let's try it. So we're going to do it. Now, the way to take the derivative of this, you either got to solve for y, so you can do it explicitly, but it would be nice if you could do it implicitly. And if you look at this answer, you really do want to do it implicitly because it has y's in the answer. So we need to do it implicitly. Okay, so I'm just going to rewrite this equation here real quick. So we're going to take the derivative with respect to x. It's going to be 2x to the first power plus 2 plus 2y to the first power dy dx. You got to follow it up by the derivative of what's inside. It's kind of like a chain rule idea. Plus 4. The derivative of 4y would just be 4. Now we got to take the derivative of what's inside, dy dx. And then derivative of 5 is 0. Now, that step right there, that's worth a point. Just by doing that correctly. Okay? Now, we want to get dy dx by itself. And so that's going to really just take a bunch of algebra. I mean, we're kind of done with the calculus here. We're just now solving for an unknown. So I would factor that out of these two terms. And I'd move the other terms to the other side. So minus 2x minus 2. And then we divide both sides by 2y plus 4. 2y plus 4. And then we're trying to make it look, if they didn't ask you to make it show like that, this would probably be a fine final answer. It doesn't have to be simplified, but we're trying to make it look exactly like that. So I think we could factor a -2 out of everything on top and factor a 2 Hold on, I made a mistake somewhere. Oh, I copied the problem down wrong. This is y to the fourth. So this would be 4y cubed. So that would be 4y cubed, and that would be 4y cubed, and that would be 4y cubed. And now I could factor a 4 out of everything on the bottom. And then we could simplify to divide a 2 out of the top and bottom, reduce the fraction, and then I think we should just leave it with the parentheses because that's the way they had it. And there we go. And we got the same thing they got. So I got a point. So that's 2 points. 1 point for the first calculus step, 1 point for all the other algebra, pulling it off correct. Okay, B says write an equation for the tangent line. I haven't asked you guys to do that ever. Okay, so if you want the equation of the tangent line, they're telling you the point, tangent to the point -2, 1. So you already have the point. All you need is the slope, and you have this equation for the slope. So even if you messed up part A, or even if you skip part A, you could do part B. Now make sure you show your work and label it, and plug it in. -2 plus 1, 1 cubed plus 1. So that's going to be -1. That's going to be +1 on the top, 4 on the bottom. So that's your slope, and that's worth a point. And then we're going to need to write the equation of the tangent line. So I just write in point cell form, y minus 1 equals 1/4. X minus -2 would be +2, and just leave it. Done. Don't do extra work. Don't change the slope intercept form. Okay, C. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. So we're looking for 2 points, 2 answers, and points probably means XY pairs, okay? And it's where the tangent line is vertical. Okay, so that means the slope, dy dx, which we've been using. Again, you could do this part without having done parts A or B or getting A or B correct. I would personally use their dy dx they told you were supposed to get. And it's supposed to be undefined because you're dividing something by 0, right? So I'm showing this, I'm trying to communicate, what my thought is, because, that could give you some credit. So that means that you need to set the bottom 2y cubed plus 1 equal to 0. And that means y cubed equals -1. And then the cube root of both sides, y equals -1. Now that's just the y coordinate. We still need to get the x coordinate. Okay. We specifically, I guess, are hoping that x doesn't equal -1. Otherwise, that's an indeterminate form. We're going to use L'Hopital's rule or whatever. So hopefully that's not happening. It could and still work, but that would just make things more complicated. Now, the fact that you got this y value, that's worth a point. Well, how do I find the x value? Well, what did you do back in Algebra 1 whenever they give you an x and you needed to find a y? You plug in the equation. What if they give you a y and you need to find the x? You plug in the equation. So we're going to plug this back into the original equation. And this is an algebra, there's an algebra idea. You have one variable, plug it in to get the other variable. So we have x squared plus 2x, and this is going to be +1 minus 4 equals 5. You want to move everything to one side. It's going to be -3 minus 5 is -8 equals 0. And by the way, just substituting y equals 1 into this equation right here, that was worth a point. Okay? And then you factor this, x plus 4, x minus 2. Now, I don't know if this is bothering anyone. They said that we're supposed to get 2 points and we only got one y value. So where's the other y value? There's supposed to be 2 different points, they said. Well, what's interesting is that this one y value gives you 2 different x's. which is totally possible. Two different x coordinates can give you the same y value. So the points are -4, -1, and 2, -1. So you want to write these xy pairs, and that is worth a point, your final answer. D says, is it possible for this curve to have a horizontal tangent at points where it also intersects the x-axis? Explain your reasoning. Are there any horizontal tangents at x-intercepts? Well, there's different ways you could do this. You could say, well, let's figure out where there are horizontal tangents, and that would be where the slope equals 0, which means the top has to equal 0. So negative x plus 1 equals 0, x equals -1 is the x coordinate where the function has a horizontal tangent. Now, there's two different things you could do with this. You could say, well, is this a y-intercept? By plugging it back into the original equation and solving for y and seeing if you get 0 or not. Or you could say, let's find the x-intercepts separately by plugging y equals 0 into the original equation. So you got different ways of doing this. So if we do this, x squared plus 2x minus 5 equals 0, and you can solve this and see if where the x-intercept is that the same location as the horizontal tangent. Now, for this, I think we can't factor it, so you'd have to use quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and you get -2 plus or minus square root of 24. You can take the square root of 4 out, and you get -1 plus or minus root 6. So these are the x-intercepts, which are clearly not at the same location as horizontal tangent. So you could say that. You could say, hey, there is a horizontal tangent, there are x-intercepts, but there are different x values. So no, the curve cannot, and you want to put that, you want to write that, you want to say something like, no, the curve cannot have a horizontal tangent where it crosses the x-axis. So one of the things that you are going to need to get used to is a lot of times we are going to write kind of, sentences for answers on free response. I don't think any of the other problems really, made it but this was worth 2 points. They said 1 point for works with x equals -1 or y equals 0. So we did both. We worked with x equals -1 and y equals 0. So we get a point for that. And then final point is the answer with the reason. So you could explain because they're at different locations. Like I said, there's other ways you could have done it. You could have said, well, let's plug this and y equals 0 into the equation and see if it gives you a true statement, because that means that point would be on the curve, and have y equals 0 and x equals -1 would satisfy both of these things. But so that's it. I'm going to go ahead and stop this video, and we're going to do the lessons separately. So I'm probably going to have you guys jump in. I'm going to do a little demonstration for you guys that'll lead into our next topic.